Next, we're going to talk about radical equations. And our one problem-solving principle that we're going to use as we solve these equations is the following fact. That if you have a equals b, then that means a to the n equals b to the n, for n being a rational number. And another important thing to remember is if you have the nth root, that is the same thing as writing that as a to the 1 over n. So for example, if you have the square root of a number, that is the same as saying x to the 1/2. So the word square coming from that word 2, so if you had a cubic root, it would be x to the 1/3. Now, so in our most basic examples, we have something like 4x plus 1 is equal to 3. And when you've got it set up this way, where you've got something under a square root equals a number, a nice number like this, what we can do is we can square both sides of the equation. And this is following this policy up here. If a equals b, this equals this, then a to some power equals b to some power. So we're just squaring both sides. And the nice thing is, on the left, we get some cancellation. And on the right, we get a number, 9. And now this is turned into a linear equation. For further clarification on why this might work, so if you have the square root of a number squared, if you follow this rule up here, that says that's x to the 1/2 squared. And if you remember how exponents work with this, this will multiply those things together. So 1/2 times 2 is 1. So this is x to the 1, or just x. But back to this, so now we've got this nice equation that we can solve. So 4x is equal to 8, so x is equal to 2. Now, as with rational equations, we want to go back and check our answers, okay, to make sure we're not doing anything wrong. With rational equations, we didn't want to divide by 0. With radical equations, we don't want to take the square root of a negative. So if we take x equals 2 and plug it up in here, we do, in fact, get a positive number. So there's no problems here. Along the same lines as that one, we could look at a function where maybe we have a cube root instead. So let's say we've got the cubed root of 2x plus 1 is equal to -5. So how would we solve this? Well, just like before, when we had a square root, we squared both sides. Here we have a cubic root, we're going to cube both sides. So when we cube both sides of this, on the left, the radical goes away, and we're left with 2x plus 1. And on the right, we get a -125. Now, solving for x, we subtract 1, and we get 2x is equal to -126. Dividing by 2, we get -63. Now, where things get more interesting for us is when we have a square root plus a little something extra. So let's say we've got x minus 2 plus (3) equals 4. Plus x. Now here we've got a problem. We've got an x on both sides. We've got the x under the radical. So the big goal here is to get x out from under the radical. So what we might do is we might subtract the 3 from both sides and get the square root by itself on the left. And so we get 1 plus x over here. Now, to move on with this, we would try to, we would square both sides. So we get x minus 2 is equal to 1 plus x squared. foiling, we get x minus 2 is equal to 1 plus 2x plus x squared. And now what type of equation is this? Well, it's a quadratic. So what we would do is get all the terms on one side, and we'd have 3 plus x squared is equal to 0. Now, we could try to factor this thing, we could try to hit it with the quadratic equation, but if we check the discriminant on this guy, negative b plus, which is the b squared minus 4ac, we are going to see that we don't have an answer, because this is 1 minus 12, which is negative 11, which is less than 0. So this is going to have no solution. Okay. So let's look at something where maybe we do in fact get an answer. So we don't have to change much to make this work. So let's take the square root of x plus 3 minus 1 is equal to x. So maybe you want to pause the video right now and try to answer this on your own using the technique we started using last time. So we add 1 to both sides. We get square root of x plus 3 is equal to x plus 1. We've got the radical alone on one side, so we square it. We get x plus 3 is equal to x plus 1 squared. We FOIL. Now when we try to get all the x's on one side, we're going to get something a little nicer. We're going to get 0 is equal to x squared minus plus x minus 2. Does this factor? It does. 0 equals x minus x plus 2 times x minus 1. So we get two solutions to this. We get x equals negative 2 and x equals 1. So again, we have to go back up to our equation and check to see if this makes sense. So on the one side, if we plug in x equals 1, so if we take x equals 1, on the left we get the square root of 1 plus 3, and on the right we get 1 plus 1. And so we get the square root of 4 equals 2. Which is good. Those are true. That's a true statement. Now on the other hand, if we plug in x equals negative 2 into this equation up here, we get that negative 2 plus 3 is equal to negative 2 plus 1, which is square root of 1 equals negative 1. So this says that 1 equals negative 1, which is not true. Meaning, x equals negative 2 is not a solution to my problem here. So we have to be careful when we're checking radical equations, that we actually get something that is